All right, so moving on to section 5 out of the 6 sections in this first chapter, we are looking at scatter plots. Okay, so scatter plots are used a lot in statistics. They're a way to identify any type of pattern that's being formed with a given set of data that might not be able to see any other way. So basically what a scatter plot is, it's a graph that shows the relationship between two groups of data. Okay, so it could be, doesn't really matter what they are. It could be time and height. It could be speed and age. It could be almost anything that you want to see if there's a relationship for. Okay, and we're just going to graph them. So this would be an example of what would be called a high positive correlation, and the reason it's a positive correlation is because as the x value, so the value down at the bottom, this value, as the x value increases, the y value also increases. Okay, so as the x value increases, the y value also increases, and that makes it positive. The reason why we would call it a high correlation is because if you look at all those dots, all the dots are fairly close to each other. Okay, they're not spread out wide, they're all fairly close. We'd call it a high positive correlation. Okay, the main thing here though is that you're mostly going to want to be identifying if it's a positive correlation or not. The high-low isn't going to come into much effect for this class. That would be more for a stats class or an Algebra II class that you'd want to talk about. If it's high-low, you talk about the R in R squared numbers for these. But for this, we're just kind of looking at positive, and then the next one would be a negative. So this would be an example of a high negative. Again, it's high because the data is close together, so that's why it'd be high. But when it's a negative correlation, as the x value increases, you see the y value is decreasing. Okay, so as the x is increasing, the y value decreases, or this graph is slowly dropping. Okay, that's your negative correlation. So positive correlation ends up going up, negative correlation goes down. Fairly straightforward, pretty simple. Last one is a no correlation. So basically with a no correlation, that means that there is no relationship. You don't see it increasing or you don't see it decreasing. There's just kind of dots all over the place. So if you see here, it's just kind of a big old cloud. It doesn't look like as you go one way you're increasing or you're decreasing. You don't really know. They're just kind of all about. And that means there's no correlation. We don't know what it is. Okay. There's also a constant correlation, which basically means it's flat, but you don't have to worry about it in this class. This class, we're going to be worried more about your negative and your positive correlations. Those are the key ones that we're looking for in this no correlation. Okay, so when we are graphing these, so in problems where you'd have these, if you have to identify if it's a positive or negative or no correlation, you're going to have to graph the data to see. For the most part, you'd end up with a lot of data points for this. When you make your graph, you have to have your x and your y-axis. So your x-axis is going left and right, your y-axis is going up and down. Going right is positive and up is positive also. The other direction would be negative. When you're usually graphing scatter plots, for the most part, they're just going to stay in that first quadrant in the positives for both, left and right. And you have your x and y, which, as it states on the screen, the x-axis is your independent variable, your y-axis is your dependent. Sometimes you'll have to identify which is which and then graph it. Other times they will be told to you. Now the positive and negative correlations or no correlations have no effect. So if you switch your independent and dependent variable, you still will actually get the same correlation. It's just the points will be slightly different. Okay, so if we take this and we graph it, okay, and we want to label these points, let's go through and we'll graph this. So starting with the first one, 2, 4, we'd go over 2 and then we'd go up 4. And that would be our first point. Next point, 3, 2. So the next point is 3, comma 2. And the last point, 4, comma 1, goes there. Okay. So 4, comma 1. Again, remember, the x is along the left and right, y is up and down. So if we look at this, would this be a positive or negative correlation? This one, I would probably say it would be more of a negative correlation. Okay, so this would be more of a negative correlation because we could draw a line going down. Okay, so it'd be more negative than anything else. Okay, so take a second and graph these, and then identify if it's a positive correlation, a negative correlation, or no correlation. All right, so with this, let's graph these points. So we have 1, comma 4, 2, comma 5, 6, 6, comma 3, 1, 2, 3, 6, comma 6, 6, comma 3 disappeared, 4, 2, 5, 0, and 3, 1. So looking at this, would you say it's a positive, negative, or no correlation? I would probably say it's a no correlation. So there's not really any line that you could use that would make sense. It's not as one's increasing, the other one's decreasing, or they're not both increasing. So I would say this is a no correlation. Okay. So there's a no correlation for this one. Okay, so your homework is section 5. Most of it is graphing. Make sure you use graph paper for this, and for graphing your x and y coordinates.